Okay, hello. This is Kyung-Seok Lee working in Inorganic Metrology Group in KRISS. I'm going to introduce our KRISS case regarding to activities using mass spectrometry for radioactivity, which is a collaboration experience between Inorganic Metrology Group and Ionizing Radiation Metrology Group in KRISS for uranium and thorium measurements in naturally occurring radioactive materials. In South Korea, in 2011, a new law called the Act on Protective Action Guidelines Against Radiation in the Natural Environment was enacted and revised in 2021. The purpose of this act is to prescribe those matters concerning safety management of radiation encountered in environments, thereby protecting the public health of people and the environment as well. Nuclear Safety and Security Commission, in short, NSSC in Korea, was responsible for the enforcement of the law. Okay, here is the regulatory system in Korea regarding the safety control of radiation from naturally occurring radioactive materials, so-called NORMs, norms. In this regulation frame, Korea Institute of Nuclear Safety, KINS, you can see the red one. This institute is operating an environmental radiation monitoring networks consisting of around 200 sites, including some laboratories. They asked for collaborations to obtain more reliable measurement results to KRISS side. There have been two kinds of collaborations. The first one is the development of certified reference materials for this regulation. And the second one is the proficiency testing using the CRMs with Korea Laboratory Accreditation Scheme. At that time, only limited number of CRMs was available, especially for NOM, like phosphogypsum, which is released, which is provided by IAEA. In Korea, the norm is specially categorized in the regulation in Korea. So we have to develop some reference materials for these regulations. Therefore, colleagues in KRISS ionizing radiation metrology group, you know that the CCRI side have tried to develop CRMs with matrices categorized as norms in Korea. They prepared already candidate CRMs and they wanted to assign property values to them, like the research outline in this slide. Okay, the measurement was absolutely the activity concentration in becquerel per kilogram. And the candidate CRM samples were three kinds of norms. For example, phosphogypsum, which is the byproduct in production of fertilizer. And the bauxite, you know that the bauxite. And the last one is the zirconium silicate. Then the measurement method at the first consideration was alpha-spectrometry. They wanted to validate their procedure and to be sure their measurement result by using ICP-MS. In my group, the SysChem side. Okay. Here is the experimental scheme for alpha-spectrometry. Target isotopes were three isotopes of uranium, so you know, 238, 235, and 234. And for thorium, two isotopes, 230 and 232. And the measurement result from alpha spectrometry was the consensus value from result of 5 laboratories, including KRISS. In KRISS, my colleagues try to dissolve the samples by applying alkaline fusion and separate the uranium or thorium from the samples by using ichromoanion and Uteba resins, as you know. And for the calibration of alpha spectrometer, the NIST uranium-232 and analytics thorium-229, which has certified values for activity concentration. So these standard was used for the calibration of alpha spectrometer. And also, my colleagues carry out a kind of a method validation using IAEA 434, the phosphogypsum, the reference material. You can see the sample dissolution steps in the photos, and separation by resins and alpha spectrometry experiment. Okay, and in this slide, I briefly outlined the experimental scheme for ICP-MS. Okay, the sample was the same with the previous, and the target isotopes are only the uranium-238 and thorium-232. And we also try to dissolve these samples by applying the alkaline fusion. You can see the alkaline fusion scheme using lithium borate and lithium bromate, kind of the plugs. But in this case, for ICP-MS measurement, we did not separate uranium and thorium from the samples. We directly measured these isotopes by ICP-MS. And the calibration strategy was standard addition ICP-MS with the thallium internal standard. At that time, we could not use the isotopes because our laboratory cannot use some radioactive isotopes above the environmental level. So at the time we used the standard addition ICP-MS. But this standard addition ICP-MS was also used for the key comparison for the other samples in CCQM studies. And also for standard addition approach, if you do not use the internal standard, then the uncertainties were unacceptable. So anyway, okay, here are the steps, the experimental steps. Okay. Okay, here are the data from the mass spectrometry measurement and the alpha spectrometry. As you know, that uranium-238 and thorium-232 were only measured by ICP-MS. I'm showing you these two data only. But in phosphogypsum samples, for uranium-238, we can see the agreement with each other between the alpha spectrometry and ICP-MS measurements. But unfortunately, thorium-232 in these sample, the alpha spectrometry cannot measure these thorium isotope because of very low concentration. But using ICP-MS, we can obtain we could obtain the measurement result. Yeah, the uncertainty is a little bit different for evaluation of uncertainty because the ICP data are based on 10 self-samples from one sample. But in the case of the alpha spectrometry results, had the inhomogeneity effect because they measure the 10 samples for the evaluation of the homogeneity. Okay, so I think that in this slide, that for specific isotopes, ICP-MS can be advantages than the alpha spectrometry. Okay, here are these two isotopes in both sides. Unfortunately, in this case, the alpha spectrometry result are not in good agreement with the ICP-MS result, and yeah. And this is the uranium 238 and thorium 232 in zircon. In this case, fortunately, the two measurement result are in good agreement with each other. Yeah. Okay, this is some data comparison. Okay, that is all the measurement result. And I'd like to quick summarize the result. That the ionizing radiation metrology group and the inorganic metrology group in KRISS has collaborated for the development of certified reference materials. And ICP-MS can be used for the method validation of the alpha spectrometry. And it can be advantageous in the measurements for specific isotopes with lower activity concentration than alpha spectrometry. And I think that the activity concentration in becquerel per kilogram measured by the alpha spectrometry can be directly linked to the mass fraction or the concentration which have meteorological traceability to the other SI units through mass spectrometry measurements by ICP-MS. Already mentioned by other colleagues in NLC and in NMIJ and other IAEA guys. And I think that the isotope ratio measurement using mass spectrometry, such as multi-collect ICP-MS or TIMS, is necessary for the more accurate comparison data, because we just applied some natural isotope abundances for data evaluation. Okay, that's all. Thank you for your attention, and I appreciate my colleagues in Kainak and KINS. Thank you again. Any question or comments,
Thank
please?
you. Thank you. I do have a question for you from the chat. With thorium 232 in phosphogypsum, what was your sample size?
In the case of the phosphogypsum size,
Yes.
I'm not remember the exact exact figures, but the phosphogypsum case also. Okay, let's see the powdered one. We already when we prepared these candidate cerium samples, we grinded all these samples and homogenized using the vmixer. So
yes,
maybe so maybe 200 micrometer or less than 200 micrometer, because we applied the meshes with 200 the micrometer size. Yes.
Great, thank you.